In November 2025, China commissioned the Fujian, an 80,000-ton aircraft carrier featuring electromagnetic catapult systems similar to the American USS Gerald R. Ford. Chinese state media celebrated it as proof that China had achieved parity with American carrier technology, noting the cutting-edge electromagnetic catapults represented capability that only two nations in the world possess. The commissioning ceremony featured extensive coverage, emphasizing Fujian's size, sophistication, and strategic importance for China's naval ambitions. The Fujian looks impressive in photos and videos. The massive flight deck, modern island structure, and electromagnetic catapult systems create an aircraft carrier that appears comparable to America's most advanced carriers. Chinese military commentators described scenarios where Fujian operates far from Chinese shores, projecting power across the Pacific and fundamentally altering the regional military balance. But then CNN published a report based on analysis from carrier aviation experts that revealed an embarrassing problem. The Fujian's flight deck configuration creates launch and recovery conflicts that prevent simultaneous operations. According to these experts, Fujian is not as capable as a 50-year-old United States ship in one key respect, specifically the USS Nimitz. The Nimitz was commissioned in 1975 and is currently the oldest carrier in the United States fleet still in active service. The problem is not the catapults themselves, nor the ship's propulsion, nor even the aircraft. The issue is the flight deck layout, the physical arrangement of catapults, landing area, and aircraft parking spaces. China designed the deck configuration from scratch without the decades of operational experience that informed American carrier design. The result is a modern carrier with cutting-edge technology, but a flawed deck layout that reduces operational effectiveness below what 50-year-old American carriers achieve. Today, we are going to examine what is wrong with Fujian's flight deck, why this matters operationally, and what it reveals about the gap between building impressive-looking hardware and designing systems that actually work as effectively as proven Western equivalents. By the end, you will understand why copying technology is not enough when you lack the operational experience that teaches you what works. Let's start with the specific problem, because understanding the flight deck issue shows why experience matters so much. Aircraft carriers conduct two primary flight operations, launching aircraft with catapults and recovering aircraft that land using arresting wires. Efficient carriers can do both simultaneously, launching from bow catapults while recovering in the landing area toward the stern. This simultaneous operation maximizes sortie rates, allowing carriers to launch and recover many aircraft quickly. The Fujian's flight deck configuration creates conflicts between launch and recovery operations. According to a CNN report citing carrier experts, the positioning of catapults, the landing area, and aircraft parking spaces means launching and recovering cannot happen safely at the same time. When aircraft are launching, recovery operations must pause. When aircraft are recovering, launches must stop. This is not a minor operational inconvenience. This fundamentally limits the carrier's ability to generate sorties, the number of aircraft missions that can be launched and recovered in a given time period. A carrier that must alternate between launching and recovering is operationally less effective than a carrier that can do both simultaneously, regardless of how advanced its catapult technology is. The USS Nimitz, commissioned in 1975, can conduct simultaneous launch and recovery operations. Its flight deck layout, refined through decades of American carrier operational experience, positions catapults and landing areas so that both can operate safely at the same time. Fujian, with modern electromagnetic catapults and contemporary construction, cannot match this 50-year-old capability because China did not have the operational experience to design the deck layout correctly. A Chinese military blogger first noticed the problem by analyzing CCTV video of Fujian operations. Not Chinese military officials, not the shipyard that designed the carrier. not the naval officers responsible for testing. A civilian blogger watching propaganda video spotted a fundamental design flaw that the entire Chinese military-industrial complex apparently missed or ignored. This reveals either stunning incompetence in design review or a culture where acknowledging problems is politically unacceptable. Now let us examine why flight deck configuration is so critical and why getting it wrong has serious operational consequences. Carrier flight operations are an extraordinarily complex choreography involving dozens of aircraft, hundreds of crew members, precise timing, and constant awareness of spatial relationships on a crowded deck. Aircraft must be positioned for launch, moved to catapults, launched, then other aircraft must be maneuvered into the landing area, recovered, moved to parking, refueled, rearmed, and prepared for the next sortie. All of this happens on a moving ship with limited deck space, where positioning errors can cause catastrophic accidents. A poorly positioned aircraft can interfere with launches. A mistimed recovery can conflict with aircraft being moved for launch. The deck layout determines how efficiently and safely these operations can occur. American carrier design evolved through more than 75 years of continuous operations. Lessons learned from World War II, Korea, Vietnam, countless peacetime missions, and unfortunately numerous accidents refined deck layouts to maximize efficiency while maintaining safety. Every aspect of modern American carrier deck design reflects accumulated experience. This catapult position works better than that one. This landing area location minimizes conflicts with launches. This parking arrangement optimizes aircraft flow. China designed Fujian from scratch without this experience base. They had specifications for electromagnetic catapults. They had general knowledge of carrier operations. They had access to photos and videos of American carriers. But they did not have decades of trial and error experience that teaches the subtle aspects of deck layout that are not obvious until you actually operate carriers extensively. The result is a deck configuration that looks reasonable on paper, but creates operational problems that experienced carrier designers would have avoided. It is like designing a kitchen if you have never cooked. You can make it look modern and install high-end appliances, but the layout will not work well because you do not understand workflow from experience. Let us talk about what former U.S. carrier officers said about this situation, because their assessment cuts to the core of the problem. According to the CNN report, former U.S. carrier officers familiar with Chinese naval development said that Chinese naval personnel do not know what they do not know about carrier operations. This is not an insult. It is an accurate assessment of experience gaps. When operators lack operational experience, they do not even know what questions to ask or what problems to anticipate. Another former officer said that all carrier operational rules and regulations are written in blood. Every safety procedure, every operational guideline, every design consideration came from accidents in which someone died. Carriers are inherently dangerous. Operating high-performance aircraft from moving ships involves enormous risks. The procedures and designs that make modern carrier operations relatively safe came from learning through tragedy what does not work. China has not paid that price in blood yet. They have operated carriers for barely over a decade. They have not had generations of sailors and pilots dying in accidents that teach what to avoid. They are trying to compress 75 years of American experience into 10 to 15 years of their own operations. And the Fujian flight deck problems demonstrate they are missing critical lessons that only come from extensive experience. This is not something technology theft can overcome. China can steal plans for electromagnetic catapults. They can hack into databases with carrier specifications. They can acquire technical manuals through espionage. But they cannot steal the accumulated institutional knowledge that comes from 3 generations of carrier operations, countless exercises, multiple wars, and yes, many accidents that taught what works and what does not. Now let's examine the broader implications of this problem for Chinese carrier operations and what it means for Fujian's actual effectiveness. Sortie generation rate, how many aircraft missions a carrier can launch in a given time period, is a critical metric of carrier effectiveness. Higher sortie rates mean more aircraft overhead providing protection, conducting strikes, gathering intelligence, and accomplishing missions. Lower sortie rates mean fewer aircraft available at any given time, reducing the carrier's operational impact. U.S. carriers with efficient flight deck layouts can generate very high sortie rates during intensive operations. During Operation Desert Storm, U.S. carriers generated hundreds of sorties per day through continuous, efficient launch and recovery operations. The ability to launch and recover simultaneously enables this sustained high tempo. Fujian's flight deck problems mean it cannot match these sortie rates even if every other system works perfectly. Having to alternate between launching and recovering aircraft, rather than doing both simultaneously, automatically reduces maximum sortie generation capability. The carrier might have cutting-edge catapults, modern aircraft, and well-trained crews, but the flawed deck layout creates a bottleneck that limits overall effectiveness. For combat operations, this matters enormously. Imagine a Taiwan scenario where Fujian needs to maintain constant combat air patrol, conduct strike missions, and provide reconnaissance. The inability to launch and recover simultaneously means some required missions might be delayed, gaps might appear in coverage, or overall operational tempo must be reduced. U.S. carriers without this limitation can maintain higher operational tempo with greater flexibility. The problem compounds during complex operations requiring precisely timed launches and recoveries. If recovering aircraft forces launches to pause, but the tactical situation requires immediate launch of additional aircraft, the flight deck limitation creates operational constraints that skilled commanders can exploit. Adversaries who understand Fujian's limitations can time their actions to exploit periods when the carrier's launch or recovery operations are paused. Let's discuss what China could have done differently and why they ended up with this problem. China could have copied proven American carrier designs. The USS Nimitz and later American carriers use effective flight deck layouts refined through decades of experience. China could have measured those layouts, understood the spatial relationships, and replicated them on Fujian. Instead, political and propaganda priorities pushed a distinctively Chinese design meant to showcase independent innovation rather than direct copying. The result was designing from scratch without adequate experience, which created avoidable problems. China could have operated smaller carriers extensively before building Fujian, accumulating hands-on experience to inform design choices. Liaoning and Shandong gained operational time, but they used ski jump decks, not catapults. Experience from ski jump operations does not translate directly to catapult carrier design, leaving a gap in the specific expertise needed for Fujian. American carrier development was incremental. Each new class incorporated lessons from previous classes, and designs evolved gradually based on operational feedback. China attempted to jump from ski jump carriers to electromagnetic catapult carriers without the intermediate stages that build necessary expertise. A civilian blogger spotted the spatial conflicts by carefully analyzing state media video. Military designers should have identified those conflicts in design review, simulation, or early testing. That a civilian found what professionals missed suggests either inadequate review processes or cultural pressure that discourages acknowledging design flaws until they become undeniable. Now let's look at what this reveals about Chinese military modernization more broadly. The Fujian exemplifies a wider pattern. Chinese development often prioritizes impressive-looking hardware over operational effectiveness, proven through experience. Fujian photographs well and presents as modern and sophisticated, but the flight deck flaw that limits sortie generation does not show up in staged imagery. This pattern appears in other programs. The J-20 looks like a fifth-generation fighter, but still faces engine and stealth challenges. The Type 055 destroyer looks formidable but has not been tested in combat. The DF-21D anti-ship ballistic missile sounds threatening, but has never demonstrated a realistic hit on a moving target. Procurement choices frequently favor systems that look impressive for propaganda over ensuring they function as claimed. A cultural issue that former US officers identified is that Chinese personnel often do not know what they do not know. Without combat experience, without decades of operational trial and error, and without institutional knowledge passed through generations, mistakes persist that experienced militaries learned to avoid long ago. Western military development is not flawless. The difference is that US development includes feedback mechanisms that identify problems, admit failures, and incorporate lessons learned. A cultural willingness to say this does not work, and we need to fix it, enables continuous improvement. The Chinese system appears less permissive of acknowledging failures. The fact that a civilian blogger spotted Fujian's flight deck problem before the military publicly acknowledged it suggests an institutional culture where identifying design flaws is politically dangerous. If designers, engineers, and naval officers cannot safely point out problems during development without career consequences, flaws persist uncorrected until they become undeniable. Let us be clear about what this analysis does not mean, because accuracy requires acknowledging China's actual achievements. This does not mean Fujian is useless or that China has made no progress in carrier development. Building any aircraft carrier represents a significant achievement. Developing electromagnetic catapults and integrating them into a functional carrier is genuinely impressive. The flight deck problem is serious, but it does not negate everything China has accomplished. Fujian can launch and recover aircraft, but not simultaneously, which limits efficiency. For some missions, this limitation may not prove critical. The issue is reduced effectiveness compared with properly designed carriers, not complete inability to function. This also does not mean China cannot eventually fix the problem or learn from this experience for future carriers. Design flaws can sometimes be corrected through modifications. Future carriers can incorporate lessons learned from Fujian. Given time and continued development, China could overcome current limitations. But it does mean that Fujian, China's newest and most advanced carrier, is less operationally capable than 50-year-old American carriers in fundamental ways that matter for actual combat operations. It means China's lack of carrier operational experience created avoidable design problems that copying proven designs would have prevented. You can build impressive-looking hardware and still fail to match the effectiveness of systems designed by adversaries with vastly more experience. So what is the bottom line on Fujian's flight deck problem and what it reveals about the Chinese carrier program? China built an 80,000-ton aircraft carrier with electromagnetic catapults that look cutting-edge in photos and propaganda videos. State media celebrated it as proof China had achieved carrier capability rivaling America's. The specifications sounded impressive. The technology seemed advanced. The ship appeared formidable. But analysis from carrier aviation experts revealed that Fujian is not as capable as a 50-year-old USS Nimitz, commissioned in 1975, in a key respect. The problem is a flight deck configuration that prevents simultaneous launch and recovery operations that American carriers accomplish routinely. This reduces sortie generation rates and overall operational effectiveness, regardless of how advanced the catapult technology is. A Chinese military blogger spotted the problem by analyzing CCTV propaganda video, before the Chinese military officially acknowledged it. Former US carrier officers assessed that Chinese naval personnel do not know what they do not know about carrier operations because they lack the decades of experience that teach what works and what does not. China designed Fujian's deck layout from scratch without the 75-plus years of accumulated experience that informed American carrier design. They wanted to create a distinctively Chinese design rather than simply copying proven American layouts. The result was avoidable problems that experienced designers would have prevented. All carrier operational rules and regulations are written in blood. Somebody died learning each lesson that makes modern carriers relatively safe and effective. China has not paid that price yet. They are trying to compress 75 years of experience into 10 to 15 years of operations. Fujian's flight deck problems demonstrate they are missing critical lessons that only come from extensive experience and sometimes tragedy. You can steal plans for electromagnetic catapults. You can hack databases for carrier specifications. You can acquire technical manuals through espionage. But you cannot steal 3 generations of accumulated institutional knowledge. You cannot copy experience gained through countless operations, multiple wars, and accidents that taught what to avoid. Fujian looks impressive in photos. It sounds advanced in specifications. But when carrier aviation experts examine the deck layout, they see a flawed design that limits effectiveness below what 50-year-old American carriers achieve. The impressive appearance masks operational limitations that only become apparent when experts who actually understand carrier operations analyze the configuration. This is the gap between building impressive-looking hardware and designing systems that work as effectively as proven equivalents. China is learning this lesson with Fujian. The question is whether the institutional culture permits learning from failures and correcting them, or whether propaganda requirements demand declaring success regardless of reality. Don't forget to subscribe for more analysis revealing the gaps between impressive appearances and operational reality. Thanks for watching.